points. Today I'm going to focus on the Python interface and demonstrate it in a Jupyter notebook. Let's take a look. The Python interface to CAS analytics capabilities called SWOT, SAS Scripting Wrapper for Analytic Transfer. Just like using any other Python package, you first need to import the SWOT package. In this demonstration, we assume you already have a running CAS server and you have the right authentication to connect to that server. Therefore, you only need two pieces of information to set up a connection from the Python client to the CAS server, the host name and the port number. Now we have imported the SWOT package and set up a connection. Let's look at what's in the server. A CAS server contains analytic and non-analytic action sets. An action set contains one or multiple CAS actions. We can actually use a CAS action called ActionSetInfo to see which action set has been loaded. As you can see, these are the action sets preloaded to your section whenever you start a new connection. We can use the help function to get more information. For example, let's take a look at the simple action set. As shown in the output, simple action set contains CAS action for basic data exploration and data summary. For example, summary statistics, Pearson correlation coefficient, one-way or two-way frequency tables, and so forth. Now, let us move on to the fun part. Let us analyze some data. First, we need to know what datasets have been loaded to this server. We can actually use the table info action to take a look. You can see 3 tables has been loaded to this server. Let's focus on the dataset called attrition. This is related to whether customers of a telecom company want to cancel their subscription or not. This type of activity is usually called churn or attrition. To use a CAS table, first you need to create a reference to that table using the CAS table method. Just like con, as a local reference to the remote CAS section, data1 is actually just a local reference to the attrition table in the CAS server. We are not moving or downloading the data. The simple action set provides several useful actions for data exploration and data summary. For example, let's get the summary statistics for all the numeric variables in this dataset. The table displayed here is actually a Pandas DataFrame. If you program in SAS language before, you know that the result tables from a SAS procedure are SAS ODS tables. In this new Python interface, all CAS actions generate Pandas DataFrame instead. Therefore, you can work with CAS action results just like working with a Pandas DataFrame. For example, you can use column indexing to subset the output table. Given the CAS action results are native DataFrame, you can actually use any other third-party Python packages as long as they support Pandas DataFrame. For example, you can use the PROC action to generate a frequency table, and then use the Bokeh package to render the bar chart to take a look at the customer attrition rate. Next, let's try to build some models. Logistic regression is one of the models available in SAS Visual Statistics. The model is actually in the regression action set. You need to load the action set before you use the model. Once the action set is loaded, all the actions in the action set are automatically attached to any CAS table object. For example, you can run a logistic regression model as a method on the data1 object, and the minimum set of parameters you need to specify are the target variables and the predictors. So far, we displayed all the outputs from CAS actions in a Jupyter HTML format. The SWOT package also provides a render HTML method to render the output in a SAS HTML format, which is actually very similar to the ODS output in a SAS environment. This demo provides an overview of the Python interface of SAS Visual Statistics. We hope you enjoyed it. Thanks for watching.